Hello everyone, thanks for attending my presentation. My name is Ghazal. I am a PhD student in Johnson Research Group at NC State University, and today I will be talking about my work. My topic is unsupervised residential load disaggregation based on low-resolution smart meter data and surveys in a developing country context. So today I will talk about these topics. First, we will review the motivation behind our work, the question we want to answer, and for the rest of the presentation, I will describe the data set, the goal of the presentation, and methods and results of the work. So what is the motivation for the work? This diagram is taken from a World Bank website showing the correlation between GDP per capita versus energy use of countries in 2015. As it can be seen, as the GDP increases as a representative of economic growth, the energy use per capita increases. So it is showing that development leads to more energy demand and more CO2 emissions. Therefore, load monitoring and power planning is essential in achieving a low carbon future with high renewable penetration. And such planning is challenging in developing countries with limited data. So the question that we want to answer is what model can be used in developing countries for the purpose of power planning and load monitoring based on accessible and low resolution data. There have been extensive studies in developed countries, but there is limited work in developing countries. So also existing methods are mostly based on supervised algorithms using labeled data, which is hard and expensive to achieve. At the same time, unsupervised methods needs high resolution data, which are not accessible in many instances, especially in developing countries. So to answer this question and existing challenges, we have been working on a data set of 2 years of energy use of 543 houses in a neighborhood in Karakol, a city in Kyrgyzstan. In the picture, you can see the location of Kyrgyzstan and Karakol, and you can see that you can also see the houses that we are talking about in this work at the picture at the bottom. Kyrgyzstan is an economically developing country in Central Asia and has a cold climate. We also have used survey data from the same houses in the energy data set we have. And this survey data set contains information about the appliances in each house, number of rooms, number of light bulbs, and building materials. So the goal of this study is to propose a model that can disaggregate low-resolution energy use signal to the end users without access to labeled data. And that is why we call this method unsupervised. And the proposed method also provides system monitoring and demand forecasting model in developing countries. So in this slide, the diagram is showing the overall workflow of the method. The first step is using hidden Markov model algorithm on the energy data set we have. In this step, we extract the chain of activities of the household in each day, as well as probability of activities based on behavioral patterns. In the second step, we use Energy Plus, which is a whole building energy simulation program to simulate the energy use of the houses based on chains of activities, appliances in each house, and building properties which we already get from the survey data set. In the last step, we will have the simulated energy use of the houses that provide the energy and use categories based on the involved appliances in the simulation process. So in this slide, I will talk about the details of the first step of the method, which is using the hidden Markov model. To extract the activity chains of the household we have in our data set, we have used active energy, reactive energy, and the time of activities as the features. And we also provide a small set of initial guesses of the energy use range of appliances to the hidden Markov model by using k-nearest neighbor algorithm trained on public label data sets. So we do not need to have label data from the context we are working on. In a Markov model, provide the chains of activities during 24 hours of a day and the probability of using appliances based on 5 states that are already defined for the model. And these states are standby, cooking, entertainment, resistant heating, and housekeeping, and all of their combinations. So in the second step of our method, we use the extracted probabilities of use along with weather data of charcoal and information from the survey data sets such as number of appliances, number of light bulbs, architectural model, and water tank capacity as inputs for Energy Plus program. Energy Plus is an open source whole building energy simulation program funded and developed by DOE. The probability of use of different appliances are imported as a schedule to Energy Plus. The schedules in Energy Plus are the rules defining the amount of use of appliances in different hours of day or even week and year. So the energy use is simulated based on the results we get from hidden Markov model. And the outputs are the hourly energy use of the household with known subcategories of end users. From this slide on, we will review the results of applying our method on parts of the mentioned data set. So the diagram at the top is showing the actual energy use for several days in September 2019, while the bottom one is showing the simulated energy use using the activity chains extracted from hidden Markov model. And the diagrams are showing the energy used in each hour of the day. So it can be seen there is a great match between the simulated and actual energy use profile and also the pattern of use. The red line in both graphs is showing the average of use in days presented in blue. In this graph, the monthly amount of actual and simulated energy use of one of the houses are compared. The difference is small, as you can see, which can be a proof of the accuracy of the extracted activity chain from the hidden Markov model. This chart is showing the end users categories resulted from the simulation for different months of the year. Most of energy use is in the resistant heating category, which includes water heater and space heater energy use. This result is predictable for us due to the cold climate of Kyrgyz in Kyrgyzstan. And also this result shows how our model and our method can disaggregate the whole building energy signal to appliance level views. In summary, we have looked at the mean of relative difference between actual and simulated monthly energy use over 20 simulated houses until now. The number achieved is 0.164, and the standard error of the mean is 0.025. Showing that in average, the difference between the simulated and actual monthly energy use is 16% relative to the actual energy use. This result is promising and showing the effectiveness of the method. In conclusion, using the proposed method, we can disaggregate the whole building energy signal to appliance level use with low resolution energy data coupled with simple survey data that can be easy to achieve in all countries. Also, the proposed algorithm can be applied on different scenarios of appliances for the purpose of future power planning in developing countries as their energy use pattern changes while they gain wealth. And thank you for listening, and I'd be happy to hear your comments and answer your question. Thank you.